talking about equivalent fractions. Equivalent fractions are in the same place on the number line, and they are equal to each other. I'll show you some examples. You produce them by either multiplying both the numerator and denominator by the same number, or they can be dividing the numerator and the denominator by the same number. It can be any whole number greater than 1. So let's start with that, and to help me with that, I'm going to use this pizza. So this pizza right now has one whole. I'm going to divide it in half, and now my pizza has a total of 2 parts. That's my denominator. I'm really hungry, so I'm going to eat one of those 2 parts. So 1 of the total of 2 parts is now in my belly. Now, if I wanted to, I could further divide that pizza another way, probably before I eat it. And now I've got 4 parts. So my denominator is going to be 4. And then I've still eaten 2 parts. And that is an equivalent fraction to what I had before, because I've actually taken each of these and multiplied them by the same number to get that. So 1 over 2, or 1/2, is equivalent to 2 over 4. They're equivalent fractions. Say I go again. I decided to divide this pizza instead of into 4 into 8. There's 8 total parts when I put them together to make the whole, and I have eaten how many of them? 4. So that's an equivalent fraction there. 1, 2, 3, 4 parts is the same. 4 out of 8 is the same as 1 out of 2. Another way to look at it, maybe my pizza starts by being divided into 6 parts. So my denominator is 6, and I'm going to eat 1, 2 of those pizza pieces. So 2 out of 6 is what I've eaten. Another way to look at that is that if I reduce that and I divide each of these by 2, so both the numerator and the denominator by the same number, then I get 1 over 3. And sure enough, it is 1/3 of that pizza that I have eaten. So, and that way I've divided it. Now let's look at your notes and put it into practice. So equivalent fractions for 2 over 3, all I need to do is keep multiplying the top and bottom numbers by the same number. So 2 times 2 is 4, and 3 times 2 is 6. I have made myself an equivalent fraction. I can multiply them both. Let's go by 3. 4 times 3 is 12, and 6 times 3 is 18. We have another equivalent fraction, and so that keeps going on and on. In that way, I have multiplied them. So tell me true or false. Is 1/3 equal to 3 over 7? Well, if I multiply 1 by 3, I get 3. But if I multiply 3 by 3, I don't get 7. Sorry, Tennessee. So they are not equal to each other. Let's look over here. Is 4 over 5 an equivalent fraction to 20 over 15? Well, 4 times 5 equals 20. Does 5 times 5 equal 25? It does indeed. So they are equal to each other. Now, the other way around, instead of finding equivalent fractions, is to simplify fractions in their simplest form or their easiest form, the most convenient form. And to do this, we need our old friend, the highest common factor. So let's look at some examples. Write these fractions in simplest form. I need to find the highest common factor between 12 and 20. So if I go through and work out all the factors of 12, 4, and all the factors of 20, which one is going to be the highest in common? Looks like, gee, that's a 10. That's real sloppy. It's going to be this. So I'm now determined that 4 is my highest common factor between those two. So I'm going to rewrite 12 over 20. 3 times that highest common factor gives me 12. And what is it? Oh, it's 5 times that highest common factor gives me 20. So that allows me to cancel that out. And lo and behold, I've got the simplified version, the easiest version of that fraction. Same thing over here. What is the highest common factor between 7 and 42? Well, I can tell you right away that that is 7. 7 doesn't have any factors besides itself and 1. So 7 times 1 is 1, and 7 times what is 42? I think it's 6. So now we can cancel out our buddies, the 7, and we have 1 over 6. And here's your work.